Thank you very much. That was some kind of welcome. Okay, so I want to talk about what I consider to be the holy grail. The holy grail in IT. It's how to cut things apart and how to put them back together. This has actually been at some of the core things that I've been doing in all of my career for a long, long time. And it didn't really matter what kind of specific technology we were talking about. This was always kind of the main goal. And every time a new technology comes up, every time somebody introduces a new way of separating things, we sort of have very, very similar discussions. So that is something I'm going to spend a little bit of time talking about. But I'm also going to fulfill one of the most important needs these days, which is that every single talk has to somehow be related to microservices. So I'm going to do that as well. And I'm also going to talk about some variants of those and about some of the patterns and anti-patterns that we found. And finally, I'm going to try to connect all of this to organizational aspects, which I think are more often than not the main motivation for doing all of this on a larger scale. So essentially, this is the holy grail because everything is so easily accessible and simple, right? All this is about is how to, well, separate things and how to make good decisions about those separations. When should we put something into its own part, and when should it be stuck together with something else? And of course, we also need to join things that belong together on the other side. So we need to find a way to distinguish between the things that have a close connection and the things that are separated. And this has been true for basically a ton of technologies over the course of time. So for example, all of these things, I've used the most generic term that I could think of, building block. For all of these things, you can have similar discussions, right? Whether you're talking about libraries and you're doing good old library design, or whether you're talking about your basic procedures in a procedural programming language, or whether you're talking about some kind of modular structure, some module, or even when today you're talking about containers, when should you put things into the same thing, when should you separate them out, is sort of the core connecting thing of all of those things. And I've made sure that to put some of the more modern things here as well, like microservices and lambdas, because essentially we rediscover the same things over and over again. And there are some commonalities between those things, even though they differ a lot. So some of the similarities and commonalities between all those different kinds of building blocks are that, for example, they have a boundary, right? There's something that's within that thing and something that's without. You make a conscious decision, hopefully, about what goes in that box and what doesn't. They have dependencies, and most of architectural work, oh, that's pretty cool. I think I'm going to refrain from using this presenter in the, seems not a good idea. That was the fast forward version of this presentation. So we have boundaries and we have dependencies, and most of architectural work, in my view, is about managing the dependencies between those things, right? That's what we do. We try to minimize dependencies, we try to manage them where they can't be avoided, and we try to avoid them wherever we can. If we have one of those things, if we have a dependency, we want that dependency to connect to that thing through a clear interface of some kind. Could be a generic interface, could be a specific interface, but it requires our attention. We need to take a look at it. All of those things, all of those building blocks typically live inside an environment of some kind. If you have like a loadable module, maybe a DLL on Windows or a shared object on a Unix system, they are connected to the process model of the operating system. And this analogy holds true for any level of module that you're talking about. We always have an environment in which they live. And if we talk about interfaces, we also have to talk about the implementation, the thing that fulfills the promises that interface made. That's sort of the inside of the box, the implementation details that we want to be able to change without having to change the interface, right? This is all true for all of those things. As are the generic discussions about loose coupling on the one hand and high cohesion on the other. That's essentially the more academic way to rephrase what I said before, right? Cutting things apart that don't belong together and joining them if they do, right? We want things to be highly cohesive. The word is actually pretty interesting because cohesive means that things stick together without glue, right? You don't have to make them stick together in some way. They naturally have this attraction. They sort of form a natural unit, and so they're highly cohesive. That's what you should be looking for in your modules. And you want those highly cohesive modules to have high cohesion within themselves to be loosely coupled to one another. Now, that's all very generic, right? That's essentially basic stuff that I could use for any, that I actually plan to use for any talk in the next 20 years. So the interesting question that we want to talk about is how big do we want each piece to be? And the answer is really simple and straightforward. We just make them the right size. Right? That's very, very straightforward. Now, of course, that sounds easier than it is, but there are some hints. And I'd like to introduce it to two thought leaders, real thought leaders in the microservices and distributed systems architecture space of 2018. One is David Parnas, who wrote a paper in 1971 introducing information hiding. It's absolutely fascinating. If you work with modern architectures, with microservices or self-contained systems or any of those models, if you give this 47-year-old paper a read, it's a year younger than I am, if you take a look at that paper, you can find out that it addresses a lot of the things that we have to worry about if we look at modern modularization strategies, right? We want to, if you look at the modularization approach that Parnas took in that paper, he essentially made the decision that you want to have localized decisions, right? You want to have things that sort of encapsulate one particular decision you made in one module and other decisions in another module, as opposed to separating them across the process steps. And similarly to what Parnas did with information hiding, you can read up on good old Dijkstra, another very famous person who wrote in 1974 about the separation of concerns as the driving factor in many decisions. Right? And these are really worth reading and exploring. We're sort of building on the shoulders of giants here, and it's worthwhile to acknowledge that and take that into account. Now, let's not talk about things from the past. Let's talk about microservices. In fact, I want to talk about different kinds of microservices because I think while we have some commonalities, again, between different models in that regard, and they have become the major way of modularizing systems in many industries these days, people understand them very differently. They mean different things to different people. There are some common things, right? Something most people can agree on if they talk about microservices, like they're focused on one thing, good old Unix philosophy. They're operated autonomously, right? You want to be able to operate to shut one down and start it back up without affecting the others. They're isolated in development. You want to be able to develop them independently of each other, maybe by different developers or different teams. Maybe they can have different owners. You want to be able to deploy them independently of each other so that you don't have to build a single deployment artifact like a good old, if you remember, that is an EAR file, an EAR file, and send that to your WebSphere application server. Nobody wants to do that anymore. So you have those individual things that you can deploy independently. And finally, as I mentioned before, you have these localized decisions so that people can make business decisions, implementation decisions, technical and domain side decisions local within their own module without affecting the others. This supports the idea of emerging and autonomous teams that actually can do their own thing, right? Everybody can agree on that. Does everybody agree on that? That's a reasonable thing to talk about in microservices? Can't see anybody shaking their heads. That's fine. So let's talk about the different sizes. I've actually started collecting them in sizing patterns. If you look at different ways that you can approach microservices, this to me becomes the most important distinguishing factors between different ways of how you can go about this. And I've arranged them from small to large with some other patterns in between. So let me start with a very simple example. I still use the example of a pricing engine. I'm probably going to switch it to something more technical soon, but let's start with this. With a pricing engine, you might have something that aims for calculating a price of something. Maybe it's the price of a trip in your domain, right? And there could be multiple services collaborating to achieve that goal. Maybe you have something that just calculates a particular rebate, something that checks the weather and takes it into account. Another thing that maybe takes a look at the kind of customer you're offering this to. And all of those things collaborate to come up with this one particular thing. The goal here is for each of those services to be as small as possible. They have to be really, really super small. Super, super small. And each of them only does this one thing, and none of them makes sense in isolation. It's only the collaboration that gives them meaning, right? It's the way that they work together and collaborate and react to things from the outside. So something's happening, there's a change in temperature, or somebody uploaded a new version of the pricing sheet, or some other kind of event happened of some kind. Maybe a border was closed or opened, or I don't know, the oil price dropped. I have no idea what could have influenced. All those things are reacted to by a very, very small, simple thing. And I like to call that a function as a service model, because those individual things really are functions. So it's FAS for function as a service. We have these as small as possible, and you could argue that these are actually the only ones that really deserve to be called microservices, because they're really micro, they're really, really extremely small. They're typically evented, so you have an event, and then you can register event handlers that react to that event of some kind, right? There could be multiple ones reacting to that particular thing, so all communication is typically asynchronously. And you can see examples of that, for example, in the talks of Fred George, who I greatly admire. He's a very smart person. You can find lots of videos of presentations of his online. He talks about the way this works in many examples where he uses that to, for example, within a limited time frame, like 100 milliseconds that you have before the client makes their final decision, to offer them additional things on the web page, like an additional, I don't know, if you're an airline, you'd offer a rental car. Maybe in your case, you'd offer an insurance or maybe some tour, or I have no idea what you could possibly offer. Within that time frame, you could talk to multiple services, each contributing a little bit to that offering that you have for your client there. Now, that's a very, very cool model, and I like to start, even though it's not the most common model, right? It's not what most people do. It's becoming more popular because it essentially is very, very similar to what you now see in the serverless movement, right? When you're on AWS Lambda, you have these little functions that you can register that handle events, like when a file is uploaded, or when maybe an event occurs, or when an API is invoked, right? So that's making it popular from a technical perspective. If you want to put it down, if you want to shoot at it, if you want to argue about it, you could say it's basically like database triggers, right? We used to do them in PL SQL a while ago. Now we're doing them in JavaScript and Python and Java, but it's essentially a similar model because we're reacting to events. And I think it also shares some of the problems of that, right? One major problem is the shared infrastructure dependency. The extreme distribution, the fact that you have all of those little things distributed across the space, and behavior essentially emerges from that, right? You have this common infrastructure, you have multiple invocations because you register event handlers. You can call emerging behavior what the hell just happened, right? This is actually what you observe. Some result happened, but to figure out how this actually, what led to that result is pretty hard because you have to somehow recreate the same events. If they're from outside sources, that becomes pretty hard. Well suited to fuzzy problems, it's something I like. If the problem is fuzzy, the solution needs to be fuzzy as well, and this is a very good match. Now, as I said, basically the only one deserving the name, not the most common one. The most common one is actually this one. I don't think it's the one you use, but I'm still going to mention it very briefly. This is a model where you have a bunch of services that provide maybe information about products so that you can display a product details page. And then you have services that call those services and provide higher level aggregated results. And then at the end, you have some sort of common UI that's built from aggregating all of those things, right? Sort of you have multiple services contributing to this particular thing, but their services are calling each other, and typically this happens in a synchronous fashion, right? A service calls a service that calls a service. If you're a distributed systems person, if you're a network engineer, you know that something calling something that calls something that calls something is a sign of trouble, right? This is not something you want to happen typically, but it happens. And it reminds me, as I'm an old person, of something called SOA. If we're doing it with microservices, I call it micro-SOA because that's essentially what's happening here, right? We're using the same model, this time with microservices, with a little less infrastructure, at least at the beginning. That is essentially a very popular model. Most people think of this when they talk about microservices. You have these cascaded calls of services invoking services. They're of course containerized because that's something everybody does these days for everything. But essentially, you have all of that complexity, which means that you need to address it, right? This is something that you have to care for. It's been popularized mostly by Netflix, I think. These are simultaneously the coolest company that I know. I love them. You should love them because of the name, obviously. But still, I mean, everybody loves Netflix, right? Happy Netflix customers like Netflix, and they're fantastic from a technical standpoint. The problem is that they've become the role model for everyone. Everyone now looks at Netflix and thinks they need to do the same thing. They need to build things the same thing, even if they're not at all in the business of building a video streaming portal, which is the one use case where it's actually a fantastic match, or one of the use cases where it's a fantastic match. I don't think it's a good match for many other things, and we're going to get to why that happens. Now, that's model number 2. It's got some consequences. The most important one to me is the need for all those stability patterns. You have to be really careful about services calling services. You have to introduce a lot of stuff. You have a high cost of coordination and versioning and all of those related issues. High infrastructure demand, which is not a problem if you can throw the money at it that Netflix can throw at it. But still, it makes for a lot of effort that you possibly might not actually need. It is suited for the most extreme scalability requirements, and the scalability requirements I'm talking about here are not scalability requirements in terms of the number of users, more the number of incoming parallel requests that you get, right? That's the major scaling here. I'm also not talking about scaling development teams, because I think those needs are served better by other models. And that's where I want to do a brief detour through anti-patterns, right? This is something that I see happening with clients of ours and companies in the wild that actually believe they're achieving their main goals by applying microservices. They have all of those little things, but then they have stakeholders on the outside that actually want something changed, and the change requires changes to a number of those microservices, and in fact, overlapping microservices. So what happens now is that those stakeholders want to get something done, but they have to talk to multiple teams. And all of those teams have to now synchronize the needs of all of those stakeholders. And one of them says, well, I don't want that change. I didn't ask for it. I have no time to test my software just because you break it. Stop doing that. Don't do that now. And the other one says, well, I need this feature, otherwise I cannot build my product or my new service. Now you have people fighting over the thing, and this actually hasn't helped you at all. It has made things a lot more complicated because now those changes are very likely to affect the interfaces between those things, right? So you have to tweak a number of them. It all ripples through all of your infrastructure. Essentially, you've just made your life worse. Well, you've improved your CV, but you've decreased the value of your architecture. And there's a similar way of doing that from a technical standpoint. This was sort of from the business side of things, right? But you can look at the technical side of things where you have all of those little microservices and then you introduce something like this. Did you notice that little thing appearing up there, that little gray box? Does anybody know what that could be? Any idea? Does this help? That's your little helpful platform library, right? It's what the people build that want to help everyone get off the ground faster, right? So you have a team of people who are very smart, typically the most technical people, the smartest engineers, right? They like building infrastructure, not boring business code. So they build fancy infrastructure, wrap that in a library and make everyone use it. And now the problem is that everybody relies on that fact. Everybody relies that this particular library is used in that particular version. So if anybody now has a problem, it's because of this person here, right? That's the platform person who's now involved in everything. Woe to you if you have to do any change to your platform. So that is something that you really should avoid if you want to have the benefit of decoupling, but you're not getting it if you're falling prey to that anti-pattern. And the final one is actually an organizational anti-pattern, which is the fact that in many organizations you have a classical structure that's based on the roles of people, right? You have business units that are, well, those are people who have different specializations in terms of the business model that they support. And then you have a bunch of developers who are maybe organized in a flat or without a hierarchy, right? A flat group of people with new modern things. But then you have some ops people and some people who are experts in handling the database and some people who are experts in Tech 1 and 2, right? Your SAP system or whatever it is that whatever legacy stuff you already still have around. Those things are all distributed, and now we get the same problem, giving me a chance to reuse my fancy graphics here, with the stakeholders having a need to build teams, cross-organizational units with all of the same downsides. They now have to synchronize. They have to convince everyone that it's a good idea to do something. And that's actually something that is, to me, at the core of most companies' problems. Most companies who want to move fast and get value quickly, right? They have this problem of an organization that's not aligned with the actual architecture of the stuff they're delivering. To me, that is the most important thing here. So to give you a pattern for a change as opposed to an anti-pattern, I like this thing that we'd like to call autonomous cells. Now, what we have here is an autonomous cell, a group of people that share a goal, right? That share some objective, that share some KPIs, that share some business value. And they're composed of people from all of the relevant groups. They're not only composed of DevOps people. That's kind of boring. That was a new thing 10 years ago, right? When people started to talk about that. These days, we maybe have some supporting engineers around, but everybody understands that they do have some ops responsibility and some deployment responsibility within their group. But the business belongs in here as well. Maybe even the stakeholders should be in here, right? What we should have is, what I would like to see is small autonomous groups of people that can make business decisions, that can actually deliver value and that can measure the value that they create and then improve upon what they do, right? That would be the ideal model to me of an organization. And of course, in a perfect world, the systems would just match the structure, right? Each of those groups would own a piece of the system, would own something that is a module, that is a building block, that has a boundary and an interface and an implementation and an environment, right? So this responsibility now creates something that's a little bigger than a microservice with 100 or 1,000 lines. It's something that delivers that particular value. It's explicitly not something that derives its value only by collaborating with others. It's the smallest unit that can deliver value on its own. And to me, that's a different kind of splitting up your system. And there are two more large-grained ways of modularizing a system that I'd like to talk about. The first one gets close to my goal. This example here is an order management system where you have to handle some sort of shipping of some kind, and you have multiple larger scaled things in the back, things that are related domain objects that actually form a bigger unit that can actually have their own view of certain things. And the thing I wanted to visualize here is that this might mean that you introduce some redundancy, some replication, or some overlap between those things. Because here's a little blue part, and here's a little green part in that red box. So because you want these things to be autonomous, you accept a certain level of redundancy. Because autonomy is the most important thing that you strive for. Because you want these things to be supportive for autonomous cells. And to do that, maybe you have some sort of event bus in the background. These days, everybody uses Kafka, but it doesn't really matter. You could use anything you like. I like to use standards-based things, but who cares? Something that actually allows you to handle incoming requests autonomously within that system and then fire off an event for something for the others to consume so that you can actually always deliver your value when you get a request to your clients autonomously without having this service call service pattern. Right? That's sort of the model here. Now, I've used the term context here, and that was not a coincidence. Actually, I think this is very much in line with, possibly inspired with, doesn't really matter, it overlaps very nicely with the whole DDD movement. The domain-driven design movement has a concept called the bounded context, which is sort of a separation of a boundary around a number of domain objects that have meaning in this particular context, and that are sort of isolated against other contexts, which is why I like to call this model distributed DDD. Right? This is, a very useful thing, and we see that a lot. This is now becoming a more common thing these days. Now, in that particular model, all of those things are still small. In my example on the last page, last slide, there was something like the order, a management part, and maybe the accounting part. They have their own contexts. They communicate using basically what I just said in big letters. They're also containerized because everything is containerized these days. And there are a number of companies doing that. I don't have some of those shiny, prominent examples that publicly talk about it, but there are a lot of companies doing exactly that. Right? I think it's a reasonably cool model. I think it addresses some of the things that we strive for when we want to decouple teams. For example, it explicitly addresses loose coupling between those contexts. That is a key goal. The separation here is built to ensure a maximum of parallelizability during development, right? You want to be able to have those things operate in parallel. It acknowledges that these contexts evolve separately, right? You don't want to synchronize the release. You don't have a new release of the platform. You want to have independent units who can do that independently of each other. The asynchronicity increases stability for obvious reasons. I'm not going to go into that. I think I've mentioned parallel development. Now, there's one thing missing to me. Even though I like this one very much, I still think it makes a fundamental misconception, which is that this UI thing is the easy part, right? That is something that I observe among back-end architects. Back-end developers always consider themselves to be the kings and not queens, not so often, but the rulers of the earth, because they do the important work. And everybody who handles user-facing stuff, they're basically just sprinkling little pixie dust on, make it pretty for me. And I get so annoyed, it really makes me angry these days, probably because like an ex-smoker, I'm used to be one of those people. I used to look down on people who did front-end work. I don't do that anymore, because I've come to respect that a lot. I now think it's the actual important thing. In a back-end person's mind, this is the idea. Once we have those cool services down here, we just have this tiny, small, thin layer of UI on top and everything's nice. And if you look at most existing systems, they end up looking like this. So you have all of the separation down here, but you still have a big, fat front-end monolith in front of it that has all of the problems of the past plus all of the problems of the services that you created down here, because you're not reaping the benefits. If you have something like this, then the interesting logic sits here, right? This is just basic, boring wrapping of database tables that makes, you know, that gives backend architects wet dreams, but doesn't help you with the actual delivery of value towards your actual customers. That's why I like the last model best. And I know I'm preaching to a choir a bit here, at least for some of you, which is something that is a more vertical approach, where in the example of an e-commerce site, you would have separate parts of that e-commerce platform delivered as things that have everything from the front end to the back end part. Now in my kind of weird graphic, the front end is down there, right? So the actual silos or verticals or systems would be something like, for example, user registration, or the catalog of all the products that you have, or the checkout process of actually buying something. Because when I display the catalog, I don't really have to care about how users became users. It doesn't concern me. I can change lots of things in the catalog without ever caring about changes in the registration process and vice versa. And in the same vein, I can have something that handles the checkout process that of course needs a reference to some kind of product here, but doesn't really have to know everything about products and the kinds of things that I offer and pricing strategies and whatever. It just needs to handle the actual delivery or the checkout of things. And of course, all of those parts are connected. They have connections on the UI level mostly in terms of various ways of doing that. And this model actually is what we like to call the self-contained systems model, because these things are sort of microservice-y in nature, but they're neither micro nor service. So we can't really call them just microservices. Nobody would understand this. So self-contained system is the name that a bunch of people came up with. It's not copyrighted or owned by anybody. It's just a name with a website that describes this, and so that people can refer to it. And essentially has this autonomy idea as the most important part. And that's why it also includes the UI part in the individual systems. You can see it in a bunch of companies these days. Actually, I think it's become quite popular, specifically in the last 2 or 3 years. You could argue that Amazon does something like that, even though they don't call it that. Otto calls it like that and talks a lot about it. And I believe you folks also do something similar, though I don't know many of the details. Now, the consequences of that approach to me are that because you have those larger units that are able to autonomously serve requests, you end up with different integration strategies. You do a lot of integration on the front end, which is kind of weird for back-end people, which is one of the reasons why it doesn't typically come up, because back-end people don't understand front-end parts. So that one of the things that we spend a lot of time with is talk about that. It also has the nice benefit that you don't have extra infrastructure needs, not necessarily. You can add an event bus on top of that, often we do, but you don't have to necessarily add things like service registries or fancy extra stuff beyond what you definitely need to deliver a web app in the first place, right? You have your proxies and load balancers in place anyway. You don't necessarily need to add to that. And it's extremely well suited if your main goal is to split development teams and have them work in parallel. Right? That to me is the most important reason for choosing this particular thing. Now, that's sort of a continuum from small to large, right? I've talked about different ways of cutting things apart and different sizes of that. But another key important message to me here is that this is all kind of fractal. Sorry, first, this slide. It's sort of fractal in the sense that a building block can be composed of building blocks that can be composed of building blocks, right? So even though I made it sound as if these were independent or mutually exclusive choices, you can actually combine them. And that's something that is, to me, perfectly in line with the original goal of microservices and the microservice movement, which was and is autonomy, right? You want people to have autonomy. You want individual developers or small development teams to be in charge of what they do, because you trust in what they do and you trust them to make the best decision because they are the ones with the most information about that particular topic. You want them to be in charge. Now, whether or not the Netflix model or a serverless model or maybe this DDD decomposing stuff or maybe something fancy like actors or I don't know, some space-based kind of thing, whatever you like, whether or not that is a good choice is not a choice that you can make on a company level or even on a large system level. It's a choice that you need to make on a lower level where you have one particular context. For example, if you're a video streaming company, then the needs of your users who actually video stream content will be quite different from the users who leave reviews. Because I'm pretty sure you'll have 100 to 1,000 to 10,000 times more people just viewing stuff than people commenting on stuff. So maybe just because of different scalability needs, you choose one architectural model for one and another architectural model for the other. So this means that starting from the top, you decompose into smaller units, and then you make a decision of how to go from there in each of those particular things. Which leads me to this one more thing that I want to talk about. And that one more thing is actually also a size, a particular size that I consider to be worth respecting as well. And it has a meaningful name, which is this, related to this thing, which is the monolith, of course. Sometimes your whole system should be a monolith. That's true if, for example, you're a 3-person company and you're building something that you want to show to investors 3 months from now. In God's name, don't waste your time doing microservices. That's just stupid. Don't do that. And of course, I do like everything else that I mentioned before, so I've tried to recombine my views to get across, to get over this cognitive dissonance by saying that we love monoliths so much that we should build a lot of them. Right? I mean, the good kind of monolith is the one where you actually can make fast decisions, you can refactor it easily, you can load it into your IDE in one thing, you can go from one class or one definition to the other. Everything works nicely and smoothly. That's perfect until that thing becomes too big, right? So plan for it not to become too big and build small ones. And if you have a number of those small things, then you essentially end up with a system of systems, which is essentially the self-contained systems approach, right? It's splitting a system into smaller systems, and then once you did that, you can make a decision that one of those monoliths is maybe not well built as a monolith and should be split apart into something else. More self-contained systems or some other pattern. Now, when I mentioned those things, I had this initial slide. One of the first slides was this one, right? Separate separate things and join things that belong together. And this actually looks at the individual building blocks, right? We look at a block that is supposed to have high cohesion inside, and we want to have an overall architecture that has these things that are reasonably loosely coupled, right? That's the goal that we pursue here. Now, that actually views things like this, right? We have those interconnected things, and we hopefully have maybe no circles or very few circles or well-defined circles, ideally none. Maybe we have, on some parts, we have no connection. Ideally, those things are so loosely coupled that you can release them completely independently. But there is something that you should also take into account, which is the part that you get if you take those things out, right? There is a space in which they live, right? These things don't exist in nothing. There is something there that actually connects them, and you have to consider how well you want to define this. One way is to completely ignore this and say, well, I do this, maybe I do an initial separation. Initially, I think about how many teams am I going to build. Maybe I have 100 people, or maybe I have 50 people. I want to build 10 teams with 5 people each. So I split my system into 10 parts, and I draw some arrows to show what they do, and I write responsibilities on each of those things so that the teams can start building stuff. That's a possible way to go about things. The problem now is that each of those individual parts will have to start making agreements with all the others, right? It's like, you know, it's like countries having bilateral agreements with each other. It's as if Germany and France and the UK and Italy and all the others did individual agreements, which is a possible thing, right? Or you could just do the EU, you know, and create rules that govern everything. Like the European Union has rules that sort of take that away. And this is actually a nice analogy because you either hate or you love the EU or you're somewhere in the middle, right? There's many good things, many bad things, and the same is true of any sort of architectural framework or guidelines that bind things together in this way, right? You could decide that, well, let's all agree to do RESTful HTTP with JSON payloads in HEL format with links and, I don't know, use Atom or RSS for events. You could do that, or you could decide, well, make up and use whatever you want. Now, using whatever you want is nice because you have additional autonomy. It's also kind of bad because you now have to have these individual agreements all the time. And that's a tension that you can't get rid of. It's what makes things interesting, right? This tension between having too much control and too little control is actually something that you can observe in multiple places in this whole discussion. So let me give you my key takeaways, and then maybe we have a few minutes for discussion. So there's more than one way. I think that's kind of a consultant thing to say, right? It depends. Sure, I'm aware of that, but that doesn't make it any less true. It's true. There is more than one way, and you should be aware of that. You should make a conscious choice. It shouldn't be by chance. You should consciously decide which of those patterns applies to your particular domain, context, and use case, and then pick that, because you want those particular benefits. You have to balance autonomy and control. Control isn't always bad. There are good reasons for wanting control, but there are many bad reasons too. So you should exert as little control as possible. You know, as little as justifiable, but not zero. It's always a non-zero number. And you should be sure, I couldn't go into much detail about this, that everything that you decide here is evolvable, right? There's this model called evolutionary architecture that essentially says you build your architecture not to be perfect, but to be changeable. And that, I think, is a key insight from the last few years. And that's all I have. Thanks a lot.